Something invisible is deciding whether your body burns fat or stores it right now. It isn't willpower, it isn't your diet, and it isn't bad luck working against you. It's a hormone called insulin, and it listens to one thing more than anything else: movement. Specifically, how long you move changes the message your body receives every single day. Most people believe any short walk creates the same effect on their metabolism. That belief is quietly keeping millions of people stuck in fat storage mode for years. Here's what actually happens the moment you take your very first step outside. Carbohydrates break down into glucose the second food enters your digestive system. That glucose floods into your bloodstream, and your body cannot let it sit there. Too much sugar circulating freely can slowly damage the walls of your cells. So your pancreas releases insulin, a hormone acting like a key for cells. Insulin unlocks the door, letting glucose enter your cells and become usable energy. But insulin is also whispering something much bigger to your entire body system. When insulin is high, your body assumes energy is abundant and safe to store. Fat cells hear this message and immediately tighten their grip on stored fuel. Your metabolism shifts into storage mode, holding on to every extra calorie tightly. This is where walking becomes far more powerful than most people ever realize. The instant you start walking, your muscles begin demanding fuel to keep moving. At first, they simply grab glucose that's already floating in your bloodstream. But something quieter and far more important starts happening deep inside your cells. Your muscles begin preparing special transport proteins to pull in extra glucose. This preparation does not happen instantly, and that timing changes absolutely everything. Walk for just 10 minutes and your body responds in a smaller way. Muscles burn a little circulating glucose, blood sugar dips slightly, insulin eases a bit. It's helpful, but it barely scratches the surface of what's truly possible here. Now, keep walking past that 10-minute mark and everything begins to shift. Around 20 minutes, deeper cellular signals start switching on inside your muscle tissue. Enzymes sensing energy demand begin activating, preparing your body for something bigger. Tiny transporters start moving toward the surface of your hard-working muscle cells. By 30 minutes, your muscles are doing something almost nobody talks about. They begin pulling glucose from your blood with far less help from insulin. Your muscles start acting like independent regulators, controlling sugar without waiting for permission. This is the real difference between 10 minutes and 30 minutes of walking. It isn't about a few extra calories burned during your casual afternoon stroll. It's about the actual message your hormonal system receives from your own movement. 10 minutes tells your body quietly, simply, use a small amount of energy. 30 minutes tells your body something completely different, something far more transformative and lasting. It says energy is being used consistently, so adjust the entire hormonal system. For years, so many people have blamed themselves for a metabolism that feels stubborn. They cut sugar, they try diets, they promise themselves discipline they can't sustain. Yet blood sugar still spikes, energy still crashes, and fat loss feels impossible. Over time, this frustration turns inward, quietly becoming something deeply personal and painful. They start believing something is fundamentally wrong with their body or their willpower. But the truth is far less personal and far more rooted in simple biology. Your metabolism isn't broken, it's simply responding to the signals it keeps receiving. For thousands of years, human life required constant walking just to survive daily.
Muscles stay active nearly all day, quietly absorbing glucose without needing much insulin. Movement wasn't exercise back then, it was simply an unavoidable part of life. But modern life has completely rewritten those ancient signals in just decades. Now people sit for hours, work behind screens, and barely move between tasks. From your body's perspective, muscles stay quiet for most of every single day. When muscles stay inactive, they stop pulling glucose efficiently from your bloodstream. blood sugar lingers longer after meals, forcing your pancreas to release more insulin. Over time, cells become less responsive, and this pattern has an actual name. It's called insulin resistance, and it doesn't appear overnight or without warning signs. It builds slowly, sometimes over many years, as movement quietly disappears from life. And when insulin stays elevated, your body hears one repeated word constantly: store. Fat cells receive that instruction over and over until releasing energy feels impossible. Even strict dieting can't override a hormonal environment still screaming to conserve fuel. But here's the encouraging part that changes absolutely everything about this entire story. Your muscles have an extraordinary ability to reverse this pattern almost on command. Muscle tissue is one of the largest glucose-consuming organs inside the human body. Contracting muscles create demand, and that demand changes how glucose moves through you. Instead of relying entirely on insulin, muscles activate their own glucose-absorbing systems directly. The moment you begin walking, this dormant system starts quietly waking back up. Every step sends signals through muscle fibers, enzymes, and tiny cellular energy sensors. But like most biological processes, the strength of this signal depends on time. A few minutes starts the conversation. Longer movement lets your body truly respond. Which brings us to one of the most common misunderstandings about walking today. People assume any short walk creates the exact same metabolic effect every time. You've probably heard advice like, just walk a few minutes after eating meals. That advice isn't wrong, but it hides an important detail most people miss. Your metabolism doesn't flip a single switch the moment your feet start moving. Instead, it shifts gradually, in stages, each one deeper than the one before. During the first minutes, muscles burn glucose already circulating in your bloodstream immediately. This slightly reduces blood sugar, which is why even short walks feel helpful. But insulin is still doing most of the heavy lifting during this stage. This is why a 10-minute walk helps, but only in a limited way. To understand why, we need to look deeper inside your working muscle cells. As walking continues, energy molecules called ATP begin getting used up steadily. As ATP decreases, another molecule called AMP begins quietly rising inside your cells. This shift activates an enzyme scientists call AMPK, the body's metabolic master switch. AMPK constantly monitors your cell's energy status, watching, waiting, ready to respond. When energy demand rises, AMPK increases glucose uptake and encourages fat burning immediately. But AMPK doesn't surge instantly. It builds gradually as your walk continues onward. Around 15 to 20 minutes, this activation becomes significantly stronger inside your muscles. Muscle cells begin sending more GLUT4 transporters toward their outer cellular membrane. These transporters act like small doors, allowing glucose to enter without waiting. When GLUT4 moves to the surface, glucose enters muscles without needing much insulin. Your muscle is essentially saying, "We need fuel and we'll take it directly." This is called insulin-independent glucose uptake, and it's remarkably powerful for your health. The longer you walk, the more pronounced and powerful this effect truly becomes.
By 30 minutes, your muscle cells are operating completely differently than at 10. Glucose uptake becomes far more efficient, and insulin demand drops noticeably lower now. This is why the idea that a few minutes is enough misses something. A short walk starts the process, but a longer walk lets biology fully activate. Understanding this reveals the real metabolic villain keeping so many people stuck today. For years, people blamed carbohydrates, then fat, then calories themselves for weight gain. But scientists discovered something different when they studied metabolic disease more closely and carefully. The real issue was chronically elevated insulin, not any single food you eat. Insulin is essential. Without it, glucose could never enter your cells properly at all. In a healthy system, insulin rises after meals, then returns to a calm baseline. But in modern life, insulin often stays elevated far longer than it should. This happens because blood sugar lingers when muscles remain inactive for extended periods. The pancreas compensates by releasing even more insulin to manage rising glucose levels. Over time, cells respond less effectively, requiring even larger amounts of insulin released. This is insulin resistance, and it sends a very specific message to your body. Store energy, it says, again and again, quietly shaping how your body behaves. Insulin isn't just a glucose regulator, it's one of the most powerful storage signals. When insulin is high, an enzyme called hormone-sensitive lipase becomes almost completely suppressed. This enzyme normally breaks down stored fat so your body can use it. When suppressed, fat cells become reluctant to release any of their stored fuel. Meanwhile, another enzyme actively encourages more storage inside your stubborn, resistant fat tissue. The result is a body that favors accumulation over release, no matter what. People reduce calories, exercise intensely, yet their hormones still whisper, "Conserve, conserve, conserve." But there's one system capable of interrupting this frustrating and exhausting cycle completely. Your muscles create a completely different metabolic signal compared to sitting still. Instead of relying on insulin, contracting muscles pull glucose directly from your bloodstream. Think of insulin resistance like a crowded highway jammed with unmoving, frustrated traffic. Glucose molecules struggle to enter cells, while insulin keeps pushing against congestion uselessly. Walking opens an entirely new road, bypassing the traffic jam almost instantly. Muscle contractions activate GLUT4 transporters that let glucose enter without needing much insulin. As glucose leaves your bloodstream efficiently, your pancreas senses it and relaxes insulin production. The traffic clears, and your body receives an entirely new, healthier message immediately. Instead of "store energy," the message shifts toward "energy is actively being used." But the strength of this shift depends entirely on how long muscles stay active. Short movement starts the process. Sustained movement strengthens it deeply and dramatically over time. This is why 10 minutes versus 30 minutes isn't just about calories burned. It's about how deeply your muscles engage the systems controlling insulin itself directly. Let's step inside a single muscle cell and follow this transformation happening live. When you sit still, muscle cells need only a small, steady amount of energy. Glucose enters slowly, insulin does most of the work, everything remains calm and quiet. But the moment you start walking, everything inside that cell begins changing rapidly. Thousands of muscle fibers contract and relax in perfect, rhythmic, coordinated patterns together. Each contraction requires energy, and that energy must be produced almost immediately now. Inside the cell, ATP provides the fuel that allows every single contraction.
As walking continues, ATP breaks down into ADP and eventually into AMP molecules. This shift activates AMPK, your cell's built-in, highly sensitive energy sensor system. AMPK detects rising energy demand and coordinates everything needed to supply more fuel. First, mitochondria increase activity, working harder to generate usable energy for your muscles. Second, GLUT4 transporters begin moving from storage compartments toward the cell's outer surface. Picture GLUT4 as tiny doors, mostly hidden when your body is resting quietly. But when muscles contract and stay active, those doors travel straight to the surface. Now glucose can enter far more easily than it could just minutes earlier. During the first 10 minutes, this system is only just beginning to activate. Blood sugar drops slightly, insulin demand eases a little, but capacity remains far from maximum. Now imagine the walk continuing onward, past 15 minutes, then past 20 minutes steadily.
AMPK activity increases significantly, and more GLUT4 transporters reach the muscle's surface. Glucose begins entering muscle tissue far more efficiently than it did before. Muscles start pulling glucose directly from the blood, even without much insulin present. The pancreas senses this efficient clearing and begins reducing insulin secretion in response. Now imagine the walk continuing further, approaching that powerful 30-minute mark completely. GLUT4 transporters are now highly active. Glucose uptake becomes remarkably efficient throughout. Blood sugar stabilizes quickly after meals, and insulin remains noticeably lower than before. Another shift begins here too, as fat oxidation starts increasing gradually and steadily. Your body starts conserving glucose for later, choosing to burn fatty acids instead. Because insulin is lower now, fat cells finally feel safe releasing stored energy. The metabolic environment shifts from constant storage toward genuine, healthy metabolic flexibility instead. Studies show a single 30-minute walk can improve insulin sensitivity for hours afterward. Muscles remain responsive, glucose uptake continues functioning efficiently even after your walk ends. This is why 10 minutes starts the conversation, but 30 minutes changes everything. Your muscles become a powerful metabolic sponge, absorbing glucose and easing hormonal pressure. And when insulin finally falls, fat cells loosen their tight, stubborn grip completely. When people first start walking regularly, something unexpected often happens in the beginning. Instead of feeling instantly energized, the first few weeks can feel uncomfortable and heavy. Legs feel heavier, breathing feels labored, and hunger sometimes increases in strange ways. This confuses people because walking seems simple, gentle, and far from truly demanding. The answer lies in how your body adapts to brand new energy demands. For someone who's been sitting for years, many muscle fibers have grown inactive. Mitochondria inside those cells may be functioning below their true natural capacity now. When walking becomes regular, those muscle cells suddenly demand far more energy immediately. At first, your body works harder to meet this newly increased demand fully. Mitochondria increase activity, blood flow improves, and tiny capillaries begin expanding steadily inward. Your body is essentially rebuilding parts of its own metabolic machinery from scratch. This is why early walking can feel tiring. Your muscles are relearning efficiency. But something remarkable happens as this adaptation process continues day after day steadily. Muscle cells begin increasing their mitochondria count, a process called mitochondrial biogenesis happening. More mitochondria means greater capacity to produce clean, usable, reliable energy consistently. Enzymes involved in glucose metabolism and fat burning become significantly more active too.
Your body becomes better at switching between fuel sources, a skill called flexibility. A metabolically flexible body uses glucose efficiently after meals and burns fat between. This flexibility keeps energy levels stable and consistent throughout your entire waking day. Walking plays a surprisingly powerful role in restoring this lost metabolic flexibility completely. With each walk, muscle cells become more sensitive and responsive to insulin naturally. GLUT4 transporters respond faster, blood sugar clears efficiently, and insulin demand drops steadily. Over time, these small improvements accumulate into something genuinely life-changing and transformative. Walking begins feeling easier, breathing smooths out, and energy stabilizes throughout your day. Blood sugar swings become less dramatic as your body starts behaving as designed. Instead of constantly storing energy, it learns to move between storing and using. This process requires no extreme effort, only consistency repeated day after quiet day. Each walk acts like a signal, reminding your metabolic system how to regulate. As those signals repeat, your body gradually becomes better and better at responding. But the most interesting changes aren't just physical, they're deeply psychological as well.
Because once the body starts responding, many people realize something truly important here. Their metabolism was never broken, it simply needed the right signal to wake. And walking, simple, steady walking, became the signal their body was waiting for. As insulin behaves more efficiently, subtle but powerful changes appear throughout your body. Blood sugar stops spiking and crashing dramatically after meals like it once did. Instead of extreme highs and lows, your energy becomes remarkably stable and predictable. This stability matters more than most people ever truly realize or fully appreciate. When blood sugar swings wildly, your body releases stress hormones to correct imbalance. These corrections create irritability, sudden cravings, and exhausting fatigue throughout your entire day. But when glucose enters cells smoothly, your body no longer needs emergency responses. Energy begins lasting longer, steadier, and far more reliably throughout each passing day. Hunger behaves differently too, since high insulin often signals your brain for more. This can trigger cravings, especially for quick sugar, keeping you trapped in cycles. But as insulin balances out, those relentless signals begin calming down naturally instead. Meals feel more satisfying, cravings feel less urgent, and hunger becomes more predictable. Fat metabolism becomes easier too, since insulin no longer forces constant, stubborn storage. When insulin falls regularly between meals, fat cells release fatty acids more willingly. Those fatty acids get burned as fuel, completing a cycle your body craves. This shift doesn't happen instantly, but once started, it builds real, lasting momentum. Many people experience a surprising emotional shift as this physical transformation continues unfolding. For years, they believed their metabolism was stubborn, broken, or working against them. Every attempt at fat loss felt like a losing, exhausting, deeply personal battle. But as insulin improves and energy stabilizes, that painful belief begins quietly changing. They realize their body was never trying to sabotage them at all, ever. It was simply responding to signals, and those signals had finally begun changing. Instead of viewing walking as insignificant, people start seeing it completely differently now. Each walk becomes a message sent directly to their own listening metabolism daily. A message that energy is being used, that glucose is being delivered efficiently. A message that insulin, finally, can relax instead of constantly working overtime hard. With that realization, a powerful new identity often begins quietly forming inside them.
Not someone struggling against a broken metabolism, but someone learning to guide biology. Because once you understand your body's internal processes, everything about this journey changes. The goal stops being to fight your metabolism and becomes learning to work with it. Few signals communicate more clearly with your metabolism than steady, repeated daily movement. Imagine two versions of the same person living remarkably similar, nearly identical daily lives. They eat similar meals, face similar stress, and follow nearly identical daily schedules. But one small difference quietly separates their long-term health in a powerful way. One walks consistently for 30 minutes daily, while the other rarely reaches that mark. At first, the difference seems invisible, barely noticeable, easy to dismiss or ignore. One walk doesn't transform the body overnight, and results never appear immediately anyway. But biology rarely works through sudden transformation. It works through quiet, patient repetition instead. Every day the first person walks 30 minutes, their muscles activate deeper regulatory systems. GLUT4 transporters move to the surface, and blood sugar clears more efficiently daily. Insulin no longer needs to stay elevated for as long as it once did. These subtle changes accumulate over weeks, quietly reshaping their entire metabolic environment completely. Insulin sensitivity improves, blood sugar becomes easier to control, and energy stabilizes fully. Meanwhile, the person who rarely reaches 30 minutes sends a noticeably weaker signal. Their muscles still benefit somewhat, but deeper cellular systems activate far less often. Months later, the difference becomes visible, not in dramatic weight loss necessarily, but stability.
One body handles glucose efficiently, one hormonal system stays calm, energy remains consistent. All because of repeated signals sent through something as simple as daily walking. This reveals an important truth about human biology that changes everything you thought. The body doesn't respond most strongly to intensity, it responds strongly to consistency. Your metabolism is constantly listening, watching patterns, tracking how often muscles demand energy. Walking for 30 minutes sends a clear, unmistakable pattern your body deeply understands. It tells your metabolism that movement is simply part of everyday, ordinary life. It reminds muscle cells to stay sensitive, responsive, and ready for glucose regulation. It encourages flexibility, letting your body switch fuel sources whenever truly needed most. Over time, that repeated pattern reshapes your entire metabolic environment from the ground up. So the next time you walk, remember you aren't simply burning a few calories, you're training your muscles to regulate glucose more effectively than they ever have. You're helping insulin return to a balanced, healthy rhythm your body deeply craves. You're teaching your body a pattern it evolved to follow long ago. Sometimes the most powerful changes don't come from extreme workouts or complicated diets. They come from repeating simple biological signals long enough for real adaptation to occur. The real question was never whether walking works. Science has already proven that. The real question is whether you'll stop at 10 minutes or push further onward. Will you allow your body to reach the deeper metabolic shift waiting at 30? Because when you understand what's happening inside your body, you gain real control. Small signals, repeated consistently, can completely reshape the way your metabolism truly works. And sometimes that entire transformation begins with nothing more than your very next step.